Hi. Today we're going to be talking about properties of similar triangles. REQ. What proportional relationships are formed when parallel lines or segments intersect other lines or segments? We're trying to use properties of similar triangles to find segment lengths and apply proportionality in triangle angle bisector theorems. Okay. Alright, everybody done?
No.
Oh no.
Okay, now I'm done.
Alright, here we go. First theorem that we have is called the triangle proportionality theorem. Here's what it says, guys. If a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So write down our theorem here. Again, if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. In this example, I get the fact that EF, I'm given that EF is parallel to BC. So I have triangle ABC, and I have line EF that intersects sides AB and AC. This means that AE over EB is proportional to AF over FC. Let's move on to the next one. Next, I have what's called the converse of the triangle proportionality theorem. It should be eerily familiar. Here's what it says. If a line divides two sides of a triangle proportionally, then that line is parallel to the third side. It's essentially, guys, the exact same theorem, just written the other way. This time, I start with the proportionality. I give you that AE over EB is proportional to AF over FC. If you have that information, you can conclude that EF is parallel to BC based on just that information. Let's look at it. Let's look at what this means. Okay? Alright, if I give you that, this should be parallel. If I give you that ST is parallel to UV, ST is parallel to UV. Okay? Here's what that means. That means that SU over UR has to be equal to TV over VR. Means that those sides are proportional. Okay? The parallel lines creates proportional side lengths. Well, if I'm asked to find SU, it's a very simple setup, right? X over 14 would equal 4 over 10. What are you going to do there? Solve for X. What are you going to do? Cross multiply. 10x equals 4 times 14, 14, 28, 49, 42, 56. Solve from there. I have it here. Any questions on that? That was pretty easy, right? Okay? You guys try one. Find P to N here. Take a couple minutes. Write down the diagram. Solve it away. Hi. What side am I trying to solve for here?
P to N.
P to N, correct? Okay. So this is my X. LM is parallel to PQ. So it divides the other sides of the triangle, not LM, but it divides LN and MN proportionally. There is a constant increase or decrease in the size for the change. Okay? Should have written this. 3x, 3 over x equals 2 over 5. Cross multiply, 2x equals 15. X is 7.5. Simple one, right? You got it? You start to see proportionality, right? Once proportionality clicks, guys, it never goes away, okay? So be scared, all right? Once you get it, it never goes away. And all the things that we learned the last few weeks, you'll always get them, okay? Once proportionality clicks, it'll never go away. All right. What about here? What am I asked to do here? What does the direction say? What does that something mean? Parallel, right? So verify that these lines are parallel. Remember that converse theorem said, if the sides are proportional, then they're parallel, right? If these sides, AEC and ADB, if they are proportional to each other, then DE is parallel to BC. 8 over 12 should be equal to 10 over 15. How would I find, you could, 10 times 12 and 8 times 15 is easier than that. You only have to cross multiply. Similarity ratio. Do 8 divided by 12 in your calculator. What is that decimal? So do it now. 8 divided by 12. 2/3. What's the decimal? 0.66 repeating, right? What's 10 over 15? 0.66 repeating, right? They have the same similarity ratio. Are they proportional? Si, senor. Okay? Answer the question. What does that mean that they're proportional? So what? Complete your answer. Say what? Yeah. Don't just take wild guesses at it, man. Go back to, you're the one that read what the question asked, so now answer the question. BE is parallel to BC. Okay? Got me? So complete answering the question. Alright, you guys do this one on your own. Okay, it's tricky. Give you a couple minutes to do this one. First thing.
I got 4/3.
First thing is this. I want to verify that DE is parallel to AB. How, using the information I've been given, how can I verify that? Hold on.
36 minus
State the theorem for me. You wrote it down for a reason. The converse theorem says what? You can read it. If a line divides two sides of a triangle proportionally, then that line is parallel to the third side. So what are we going to be trying to do here? Figure out the proportionality of two sides of this triangle. Okay? Alright? Without knowing what to do, you're going to be real lost. I promise. Here we go. AC is a total of 36 centimeters. How much is A to D? 16. If you got that far, give yourself a round of applause. Okay. BC is a total of 27 centimeters. How much is B to E? If you got that far, give yourself a pat on the back. Okay? Alright. That means that I gotta set these up proportionally. Check it out. 16 over 20 should be equal to 12 over 15. Gee, Mr. Hobbs, I do it now. Yep. See, if you want to go to cross multiply with blue, whatever your name is, I love it because you see the fractions, you see the equal sign, cross multiply. Hey, let's try it one time. Let's cross multiply. No. What's 16 times 15? Dude, you got a calculator, man. It I don't know. 31? 16 times 15 is 31.
240.
240. Blue. What is 12 times 20?
40.
Hot diggity dog. You could do it that way if you want to just cross multiply, okay? Alright? You with me? It's easier, I think, to do it another way, which is to divide the fractions, right? 16 over 20, 0.8, should be equal to 12 over 15. Is it? Si, senor, it is. We did 16 over 12 and 20 over 15. Well, because they're proportional, they're the same, but that's the wrong proportion, okay? Hey, check it out. Hey, check it out. Check it out. If you did 16 over 12 equals 20 over 15, you're setting up the wrong proportion. You need to set it up along the sides, although you wouldn't be wrong, okay? Because those are going to have to be proportional, all right? But you want to set this up along the sides. A over D equals D over C. I'm sorry, A over D. AD over DC equals BE over EC, okay? Set it up along the sides so that the sides themselves are proportional. What's my answer, Ms. Sudduth, to the question? Are they parallel, yes or no?
Yes.
Well, maybe if you weren't stuffing marshmallows up your nose, then you would have an idea, okay? What's the final answer I'm going to write down? Brianna? What's the question that I asked? All you got to do is state the answer to the question. What's the question that I asked? Thanks, Brianna. Brianna, tell me, what does this mean? Read it for me. This just means that DE is parallel to AB. Very good. Very good. Okay? All right, let's do this theorem. Two transversal theorem. Two transversal proportionality. If three or more parallel lines intersect two transversals, then they divide the transversals proportionally. Okay? In this case, my parallel lines are they're going across the screen horizontally. Okay? I got three sets of parallel lines cut by two different transversals. Here's what that means. AC over CE equals BD over DF. Everybody, now come over here and hit this right arrow.
No.
Check it out. We'll come back if you need it later. Alright, so on this one it says, suppose that an artist decided to make a larger sketch of the trees, because of course that's what artists do. In the figure, if AB equals 4.5 inches, BC is 2.6, CD is 4.1, KL is 4.9, it would ask you to find LM and MN to the nearest tenth of an inch. In the prior example, my parallel lines were going from top to bottom. In this example, the parallel lines are going from left to right, which means my proportion would need to be 4.5 over 2.6 equals, and I don't think y'all can see this, but KL is at the bottom, and it's 4.9. So it would be 4.5 over 2.6 equals 4.9 over X, and you would find LM. Once you found that answer, you could then go to the next set of parallel lines and say 2.6 over 4.1 equals LM over MN. Okay? Robinson, next slide, please.
You guys would just stand there.
All right, last theorem here. The triangle angle bisector theorem. An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. Just out of curiosity, what does an angle bisector do? Splits the what? Oh my gosh, guys. The angle bisector does what? Splits the angle into two what? Two. Holy smokes. Guys, the angle bisector splits the angle into two
said that.
What kind of angles? Somebody's saying it. Congruent angles. Just a quick review of bisectors, because clearly we need to hear it. Okay? In this case, angle A is getting bisected. Check out what happens here. I go to the side opposite of angle A, the side opposite of the bisector. I see it creates BD and DC. So this theorem, which a lot of you might get confused, this theorem says that BD over DC equals the ratio of AB over AC. I'm going to give you an example problem that shows that. Robinson, stand up, please. Get down in the scroll bar down at the bottom, the toolbar. Click the farthest one on the right. Down at the bottom. And recorder will come back open. Yep. You can hit pause. Alright. So check it out, guys. Thanks. Alright. Stop. Hey. Angle Q is getting bisected. What does that mean? Thank you. It's getting split into two congruent angles. Alright, so here's what a lot of you are going to make the mistake of. You're going to see this, and you can go, oh, okay, x minus 2 over 32 equals x plus 5 over 40. Yeah, that's wrong. Okay? You go to the side opposite the bisected angle, and that's your proportion. Your proportion is x minus 2 over x plus 5. That longer side of the triangle right there. Okay? That's the proportion that's set up. Equals 32 over 40. Now, if you do it the other way, you'll still end up with the right answer, but I want you to apply the theorem correctly. Okay? Everybody with me on that? Any other questions on this? Everybody's good with this one? Kinda? Sorta? Not really? Okay? Well, that's all.